we are going to talk about functions. So we are going to start this video and we're going to look at several ways that we can think about a function, several kind of definitions that emerge from this concept of what a function is. So let's start with a relation. So a relation is just, well, it's any, by definition, it's a correspondence between any two sets. So it's everywhere. You think about, first example, someone and their birthday, or for us, a lot of times it's going to be X and Y numbers we're going to think of. It could be how you use the periodic table, how, a particular element, and I'm not real good with the periodic table, it's been a long time, but how a particular element might correspond with its abbreviation or something. So kind of any relationship, it is a relation, any correspondence that we establish between two sets. All right, so what is a function then? It is a particular type of a relation. It's one where each element of the first set gets assigned to exactly one element in another set. That first set of inputs is called the domain. That second set of outputs is called the range. Let's look at these examples and decide if they meet that criteria. So example one, as we are looking, what are we looking for? We are looking so that we see that each element gets mapped or assigned to exactly one element in the second set. So each person here goes to exactly one birthday. And of course, this is a small example, but I could extend it. We all have just one birthday. So this, even if extended, even if written in general, like is birthday, would that be a function of, all the members of our class or something if we looked at extending it? It would still be true, even though this one only is a very small example, just 4 people. All right, so what is the domain going to be? So let's think about that. Our domain is the set of all input values. So we're looking at all of the members of that first set. So in this case, it is simply the people. So it would be the 4, I'm going to abbreviate here, but the Angela, the Brian, the Malcolm, and the Jeanette. So those 4 individuals would be members of the domain. The range then is the set that is being mapped to the set of all outputs. So the range here is going to be those 4 birthdays, which I'm going to kind of abbreviate here as just May 7th, the August 25th, and the January 2nd date. So those birthdays. Okay, so let's take a look at number 2 here. And so again, we're trying to decide, does each input, this time we're starting to move into our more common examples that we'll work with, X and Y values. Does each input go to exactly one output? Yes, in the first case. But then we go on to 1 and we have a problem because 1 is being mapped to both -1 and 1. So that is what is going to prevent this relation from being a function. So that is a no. We could still write out the domain and range. Most of the time we tend to talk about those with functions, but let's go ahead and do that even just for good practice. So the inputs, the 2 X values here, 0 and 1. The range, the 2 outputs, we have, 3 outputs. We have, and typically we write them in numerical order. These curly brackets are what we call a set, a roster form of just listing them out, but typically we would go in numerical order. So -1, 0, and 1. All right, so this then is like an arrow assignment. Another way that you might see, instead of arrows, is you could see it as a table of values. So on this example too, and I think you'll often see it this way as well, you could have your X and your Y, and a lot of times it's instead of columns, like they may even be written like this way as a table. and then they would just say 0, 0, because that implies 0 is being mapped to 0. And when you get to something like this 1 being mapped to two values, it would be 1 goes to -1 and 1 goes to 1. So this is another way that you might see this exact same relationship be represented. So let's just say or. So these two, you could see it either way. Probably more apt to actually see it, honestly, with that table, maybe than the arrows. Okay, so as we look at it more in that table form, let's actually focus on that for a second. If it's not that, one input being assigned, kind of that splitting, going to two different outputs, what is it that we're looking for then that would prevent this from being a function? Well, it's right here. It's this repeated x coordinate of 1 that's being mapped then to two different numbers in the y column. That's what we would be looking for if we were to focus on it from that type of a representation. All right, that leads us to another definition of a function. So we can say that a function is a set of ordered pairs, like xy values, for example, in which there is no repetition of the first, more commonly for x, for us, the x, where no first coordinate gets repeated. So as we look at maybe that table that I wrote, repeated x, that means no, not a function. Let's look at it now, listing out just as ordered pairs, which is the same thing as a table. So if I look at this first example, I don't see a repeated x. 1, 5, -3, no repeated x. So we're fine. This is a function. All right, then my domain, the set of all inputs, the three different x's, kind of written in numerical order, -3, 1, and 5. And in this example, there are two values in the range, in the outputs or in the y's. And so notice that I know that 8 gets used twice, but it's either in the range or it's not. And the same thing would be true of a domain. You don't ever list a number, although I shouldn't say that. If you had a repeated x coordinate, that actually wouldn't be a function. But still, let's say they had you write out the domain of something not a function, like we did up above in number 2. So I guess, yeah, if you're talking about domain or range, if a number is there twice, you just write it once. It's either there, it's either in that set, or it's not in that set. Okay, so let's look at another example here. So example 4, and let's think about a set. And if we were in class, I might ask some students to come up with maybe a set, let's just do 2, that's all we'll need, that is going to violate and then not be a function. And so, pause if you want to think about it on your own for a second there. So come up with your own set that is not a function. Well, I just need a repeated x coordinate. Doesn't matter what it is. So let's say it's 2. 2, -1, and maybe 2, 0, whatever the case is. And we could put a bunch more different ordered pairs if we want to. I just need one situation of a repeated x coordinate right there, and that is what is going to prevent this relationship from being a function. Okay, so again, if we wanted to talk about the domain, the inputs here, again, we typically talk about that more with a function, but the domain here would just be 2. Those are the only inputs, and then the range, we have 2 numbers in that output, so -1 and 0 there. All right, so what I want us to now transition into is thinking about some of these relationships, these functions, what this definition would be. I want us to think about it, what that would look like graphically. So as we sort of make this transition here, let's think about something for a minute. Let's take this example right here. So as we start to think about this graphically, and let's think about if we were to graph, just on our XY coordinate plane here, if we were to think about graphing these 2 points, I have 2, -1, and I have 2, 0. This is my very boring graph, right? It's just 2 points. It's pretty boring. We're going to look at a lot more involved graphs than just, a couple points. But what does the violation look like graphically if there is a repeated x coordinate? It looks like a vertical stacking of those 2 ordered pairs. So notice they stack right on top of each other. And that is kind of a third way to think about or define a function. So first we defined it as just this idea. It's a relationship where each input can only be mapped or assigned to one output. We kind of developed that into, as ordered pairs, that would mean no first coordinate could be repeated. And then if we think about taking that to a graph, what does that look like? It looks like a situation where this is the vertical line test. If I passed an imaginary vertical line through my graph, it can't ever hit the graph in more than one point. If it's able to do that, then it's a function. If it's not able to do that, like what we just saw here, if it hits in more than one point, an imaginary vertical line moving through, then it's not a function. So that's what we call the vertical line test. So let's take a look at one example, and then we'll kind of stop here and come back and look at some more next time. So here's the idea. It's the passing of this imaginary vertical line through the graph. Now, the first place, I'm okay. It only hits my graph in one point. So it's kind of like I was okay here, but then as soon as I get anywhere over here to the right, in the positive x arena, an imaginary vertical line passed through my graph. It hits that graph in more than one point, and that is what means that this relationship right here is not a function. All right, but let's talk about the domain and range anyway, just for good practice, especially from a graph. So now we're out of the arena of just a finite number of points. We're not looking at just, 3 points on the coordinate plane. We have this graph which represents this continuous graph, this line, this that's in green here. So as we look at this graph, when you can draw through graphs with this like smooth connected line, that represents an infinite number of points. Every single point that's here and then continuing off to the right is part of this relationship. Obviously, it's not a function here. But as we're looking at this relationship, the domain, remember, is the set of all x values that are on the graph. And so as we look from left to right, there's an infinite number of values. They start at 0, and then it's everything after 0. Like the first x point we see is at x equals 0, and then every x value is covered thereafter as you look to the right. So there are 2 ways to write this. And there's 2 different types of notation. So we can use interval notation, which says the first x value starts at 0 with a bracket, and then every x value is covered thereafter, so going to infinity. Or we can use essentially what's the inequality, which we kind of make just a little fancier, and we talk about it as what we call set builder notation. So those are, if you kind of just even verbally think about it, describe those x's. They're all the x's that are greater than or equal to 0 that are on that graph. So with set builder notation, curly bracket is the set of all x such that is this straight line, and then the inequality statement, x is greater than or equal to 0. So either of those would be okay here. I tend to prefer interval notation myself. but you should definitely be familiar with both. You will, see both and have to know both. All right, range. Range then is the set of all y values. So now we're thinking about, as you kind of look at the graph from least to greatest, in the y direction, that's kind of looking down, up. And because this graph does keep kind of going down, it's slight, but it does keep going down. No matter how small of a y value, eventually this graph would hit it. And then every y value in between all the way up to, and again, because this arrow keeps going up ever so slightly, no matter how large of a y value, it would have a home somewhere on the graph. So the range on this one is going to be everything from negative infinity to infinity. So the smallest value starts at negative infinity, the largest value goes all the way up to positive infinity. And then there's not really a nice inequality for that. I suppose the only other thing you could say is just to kind of somehow write out in words or indicate that the range is all real numbers, that everything is included in that range. You could just maybe write it out in words or something like that. All right, so when we come back in the next video, we'll look at some more examples, and then we'll start to introduce some function notation in the next video.